Okay, good day to you all. I will in today's class I will discuss on the activity question that we do last week. Okay, looking at the first question, this is the graph of the function f of x is given below, and you have to find the limit as x approaches -4 f of x. Right now, if you have to find the limit, what you have to do, you have to find the both sides limit, left hand side and right hand side. Okay? So when you find the limit when it approaches from left hand side, that means when x approaches -4 from negative side, that means from this side, right? When you come from this side, you first thing you will find this graph. So when you follow this graph, right, and when you approach the x value of -4, you get 0. Right? This is the point. You're getting 0. Okay? So from negative side, you're getting 0. Now from positive side, from this side, you'll follow this graph till now you have not met -4, so you still go on, and then as soon as you reach -4, again the answer is 0. So from both sides answer is 0, so answer will be 0. The final answer will be 0. Okay? So that's what you have to do. You have to find from both sides and then come to a answer. If both answer matches, then that is the limit. If the answer doesn't match, then limit does not exist. Okay. Now limit as x approaches 3 from the negative side. Let's see. From the already the question says find the limit as x approaches 3 from the negative side. So you just have to find from the negative side. Now from negative side is this side. So when you come from this side, you look for 3, x value of 3. The x value of 3, you'll find it here. Right? And when you come from this side, the graph you will meet is this graph. Right? When you graph and you see the x value of 3, the y value you get is 2. See? So that's how the r size 2. Limit is x approaches 3 from the negative side, r size 2. But for this one, right? For example, if the question was saying limit is x approaches 3 from the positive side, then you would have come from this side. When you come from this side, you'll follow this graph. Right? Follow this graph, and when x is 3, your answer will be 3. See? From negative side, it will be 2. From positive side, it will be 3. Two different answers. Right? But the question says from negative side, so you just have to write 2 is the answer. Now, next question. The graph of piecewise function is given below, and you have to answer the following questions. First one, limit is x approaches -1 from negative side. Right? You have to find x approaches -1. So what you have to do, you have to find from both sides. So from negative side, when you find, right, you are approaching -1 is here, right? So from this side, when you approach, the answer you're getting is 1, right? And then from positive side, when you go, you follow this graph. Still, you have not reached -1. Then follow this graph. Still you have not reached -1. Then you follow this graph, and the answer again you're getting is 1. From both sides you're getting 1, so answer is positive 1. Next one, the graph of g of x is shown below, and you have to find the limit as x approaches infinity. Now x approaches infinity. Now looking at the graph, it says infinity. That means it is positive infinity. Positive infinity means x value which is a very big number, very large x value, right? So the x values which is increasing is this side, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all these numbers that is increasing this side towards the right. So it is approaching positive infinity. That means we'll be following this graph. You can see this graph is going this side. Okay? And while this graph is going this side, the x values are increasing. Right? So remember, this graph will never touch this asymptote. Right? This is the asymptote, the dotted line. So this x values is this graph is going this way, and the x values is increasing. That means it is approaching positive infinity, and it is approaching which y value? Okay? It is approaching y value of positive 1. Right. So what we have done, we have looked from this side. We have approached from negative side. So when you come from this side, right, you follow this graph, you will get y value of positive 1. So that's why we have written here the answer will be 1 from the negative side. See, if you come from the positive side, then it is not approaching. If you follow this graph, it is not approaching positive infinity. See, it is approaching negative 2, this graph. If you follow this graph, this is not approaching positive infinity. It is rather approaching negative infinity, because this side is all negative number. Right? That's why we have to follow this graph from the negative side, and that's the answer. I hope it's clear. No, those were the questions that we were supposed to do on that topic, limits. Now we'll look at algebra, and under algebra we'll look at sequences. Objective: to list the terms of sequences. Sequence is an unordered list of numbers. The partial sum of a sequence is the sum of the finite number of consecutive terms beginning with the first term. Those are the two things you should know, right? Partial sums, that means you keep on adding the sequences, right? If it is 1, 3, 5, 7, 9, 11, right, that's a sequence. So if you, that's a sequence, right? And if you talk about partial sums, it will be 1, then 1 plus 3 is 4, so the next number will be 4, right? Then the third number will be 1 plus 3 plus 5, right, which is 9. So 1, 4, 9, and then so on. So keep on adding. So we'll look at those type of examples soon. Let's see. First one, the sequence. A sequence is defined by n is equal to n squared over 2n plus 1. So it says find the list the first 3 terms of the sequence. So very simple. If you have to find a1 first term, your n will be 1. So if you have to find second term, your n will be 2. If you have to find third term, n will be 3. Right? So to find a1, so instead of n, put 1. 1 squared over 2 into 1 plus 1, answer is 1/3. Similarly, to find a2, 2 squared upon 2 into 2 plus 1, 4/5. To find a3, there is error. It will be 3 squared upon 2 into 3 plus 1, you get 9 upon 7. Right? So that's how we find the sequence. Now list the first 2 terms of the sequence of partial sums. Now this is a sequence, whatever we have shown. You have to denote it like this, right? In and between the less than and greater than sign, you list the terms that you found, right? 1/3, comma 4/5, comma 9 upon 7, comma dot dot dot. Right? Now it says find the first 2 terms of the sequence of partial sums. Now as I said, partial sums, remember the first term was 1/3, second term is 4/5. So for partial sum, the first term will remain same, which is 1/3. As you can see, it is here, right? The second sum, the second term will be the first term plus second term. That is 1/3 plus 4/5, 17/40, comma. To find the third term, you will add the first term, second term, third term. You'll put it here. To find the fourth term, you add one first term, second term, third term, fourth term, and put it here. Right? I hope you got it. Right. Now let's look at question number 4, the activity question. It says a sequence is defined by bn is equal to n minus 3 upon 2n plus 4. You have to find the fifth term of the sequence. To find the fifth term of the sequence, to find the fifth term of the sequence, you have to put 5 in place of n, right? Because n will be 5. So just substitute 5 in the place of n, and you will get the answer 17. Okay? It says list the first 5 terms of the sequence. It means you have to find b1, b2, b3, b4, b5. So to find b1, instead of n, put 1. To find b2, instead of n, put 2. To find b3, instead of n, put 3, and so on. So once you put the values 1, 2, and 3, you will get these numbers, these answers, these sequences. Okay? First one, second, third, fourth, fifth. So you just put it in less than and greater than sign, and there's a sequence. Okay? Term 1, term 2, term 3, term 4, term 5. Now, if it says partial sums, as I said, the first term will remain as it is, which is negative 1 upon 3. Second term will be first term plus second term, which is negative 11 upon 24. Third term will be first, second, third term. You add these three, you get this. Fourth term will be you add all four, you get this. Right? I hope you're getting it. Now, the homework that was given to people says a sequence defined as an is equal to 2 upon n. Leave the first four terms of the sequence. Okay. So first four terms, that means in place of n, put 1 to find the answer. You'll get 2 upon 1, which is 2. In place of n, put 2, 2 upon 2 is 1. Then 3, 2, third, and then put 4, you get 2 upon 4, which is half in simplified form. Right? And then what is the limit as n approaches infinity? 2 upon n. Remember, infinity is a very big number, right? So a number, if you put infinity in place of n, 2 upon infinity will give you 0. A number upon infinity will definitely give you 0. Why? Because infinity is a very big number, right? For example, if infinity, the value of infinity is 1 million, right? So 2 upon 1 million, 0.0000, I think 5 zeros, then 2, right? So it will give you a number that is very close to 0, right? So that's why our answer is 0. Okay. Next one. Right, now I will discuss on convergence and divergence of right. This is to determine whether sequence converges or diverges. That's what you have to do. First point says sequences which approach a definite value are said to converge. So that means, for example, if you're finding the limit and you are getting, so for example, 0, 1, 2, or negative answer, any answer you're getting apart from infinity, that means that is the value to which the sequence is converging. That is the value. Right? If the answer is 0, that means the sequence is converging to 0. If the answer is 1, the sequence is converging to 1. Right? If the answer is negative 200, the sequence is converging negative 200. Right? And if the sequence has a limit, we say the sequence is convergent, and then the sequence converges to the limit. Otherwise, the sequence is divergent, meaning if the answer is if it has a limit and the answer is infinity, then the sequence is divergent. Right? Positive infinity and negative infinity, the sequence is divergent. There's the difference. So we'll look at some example. It says one sequence is given, in is equal to 7n plus 3 upon n minus 5, and you have to show and give the value to which it converges to. Right? So if it says somewhat like this, the question says somewhat like this, what you have to do, you have to find the limit. Right? You find limit as n approaches infinity. Always say limit as n approaches infinity. 7n plus 3 upon n minus 9. See, that's what is written here. Now, when it is approaching infinity, you should know one method is you divide by the highest power, which is n. Right? You divide, you cancel off, you'll get 7 on top. 3 upon n will be 0, and 1 here, n upon n is 1. 9 upon n will again get 0. So answer will be 7. That's one method. Another method is use L'Hopital rule. That means differentiate the numerator. Differentiate the numerator. Differentiate the numerator. 7, and when you differentiate, you get 7. And 3 you get, when you differentiate, you get 0. 10 when you differentiate, you get 1. And when you left 9 when you differentiate, you get 0. So you're getting 7 upon 1, which is 7. So that's using L'Hopital rule. So what is the answer? We have answered. The question was saying give the value to which it converges to. So this is the answer. The this sequence in is converging to the value of 7. Right? You are getting the answer. So you are getting a definite value. So that is this sequence is converging. So remember, you have to just find the limit, get the answer, and you will know whether it's converging or diverging and to which value it is converging. Now, second one, another sequence is given, in is equal to 2n plus 1, and determine whether the sequence converges or diverges. Right? Now, limit is n approaches infinity 2n plus 1. Instead of n, you put infinity, and remember, infinity will be infinity, and then infinity plus infinity, 1 will be infinity. So you will get an answer which is infinity. As I said before, if your answer is positive infinity or negative infinity, either of that, the limit will, the sequence will diverge. Right? So you can write the statement. Since the terms of the sequence goes to infinity, therefore sequence diverges. Right? Either it's positive or negative is written on the note here. Right? The sequence will definitely diverge. Right? Now, example 3. Another sequence is given, which is n squared upon 2n plus 1. You have to find the limit using L'Hopital's rule. Right? Let's find the limit using the two ways you can find it. You can divide by the highest power, that is divide by n squared, divide by n squared all the times, or you can just use L'Hopital rule, that is differentiating the numerator and denominator. Differentiate the numerator, we will get 2n. Bring the power in front, minus 1 from the power, n squared will become 2n. When we differentiate 2n, you get 2. When differentiate 1, you get 0. So answer you get is 2n upon 2. So you can see 2 and 2 is common. 2 and 2 will cancel from the numerator and numerator. So what is left is n. So once only n is left, so instead of n, you put infinity, and the answer will be infinity. Limit is n approaches infinity. Instead of n, put infinity as an infinity. So our conclusion is, since the limit is infinity, therefore the sequence diverges. Right? I hope I'm clear on that. Example 4. A sequence is defined by in is equal to 12n plus 1 over 3n plus 2. It says how many times the sequence are less than 3.9, less than 3.9, right? So this is how you will solve this question, right? What you will do, you will put in, it says less than 3.99, so less than 3.99, right? So what you do, you have to solve for n here. And you can see 12n here in the numerator, 3n in the numerator. You have to bring both the n's together. How you will do that? You just multiply by 3n plus 2 both sides. Right? You multiply by 3n plus 2 both sides. Right? This one, right? This part, you multiply both sides. Right? And then when you multiply this one here by 3n plus 2, right? 3n plus 2. Right? And this side, when you multiply, this will cancel. So only 12n plus 1 will be left. This side you expand. So 3.99 times 3n is 7.97n. Times 2 is 7.98. Right? Then you bring the like terms together. The like terms are 12n and 11.97n. Right? So since 11.97n is positive here, so take this that side. Right? So 12n minus 11.97n will be n. Right? It is something 0.03n. Right? And then take this one that side. So 7.98. 7.98 minus 1 will be 6.98, right? And then you divide by the coefficient of n, whatever you get, 12n minus 11.97n, you'll get 0.03n, right? So divide by 0.03 both sides, you'll get 2.67, right? And then you round it off to the um, whole number, right? Not to the next whole number, to the previous whole number, and you get 232. So n is 232. This is how many times of the sequence are less than 3.99? 232 times of the sequence are less than 3.99. Okay, I hope you have understood. See, it's given in the note. As n represents the number of terms, therefore this question is referring to the value of n that you have to solve for. Right? The question is also asking for exactly how many terms. Therefore, even though the answer comes to n, which is less than 232.67, actual number that is less than 2.67 is 232. In all of the above examples, the method used is finding the limits at infinity. The method 1 or method 2 is indicated in example 1. Always place a concluding statement towards the end if the question asks whether the sequence converges or diverges. Right? So you always have to put the concluding remarks. And you can always use method 1 and method 2. Method 1 is dividing by the highest power, right? And method 2 is using L'Hopital rule. So please take note of all these things and answer the activity questions that is there with you to solve it. Now I will show you people a short video which will this video is based on convergence and divergence of limits. So maybe if you have not understood what I have taught you, uh, by looking at this video you might understand. So please take a good look at the video and try to understand.
Convergent or divergent. So let's find out what that means. Take the sequence a sub n equals n. That means that the first term is 1, then 2, and so forth through the integers. We want to find out what this sequence does in the limit of n approaching infinity. For this one, it's easy to see that the sequence approaches infinity as n approaches infinity. So we would call this sequence divergent because the limit does not exist. Then let's look at something like a sub n equals n over n plus 1. This will give us 1/2, 2/3, 3/4, and so forth. We can pretty quickly see that this sequence will approach 1, but never quite get there. So the limit of this sequence as n approaches infinity is 1. Because the limit exists as a finite number, we would call this sequence convergent.
Let's look at this first sequence here where a sub n is equal to n raised to 4 plus 3n all over 4n cubed minus 2n plus 1. Recall that to show that a sequence is convergent, we need to show that the limit of a sub n as n goes to infinity exists, which means it's a real number. If the limit does not exist, then we say that the sequence is divergent. So let's compute for the limit of a sub n as n goes to infinity, which is equal to the limit as n goes to infinity of n raised to 4 plus 3n over 4n cubed minus 2n plus 1. So this is similar to computing limits of rational functions. So as n goes to infinity, this goes to infinity, this goes to infinity. But our technique when we're computing limits of a rational function at infinity is to divide the numerator and denominator by the highest degree term in the denominator, excluding the constant. So you may exclude this coefficient here, which is equal to 4. So we just have to divide the numerator and denominator by this highest power of n in the denominator, which is equal to n cubed. So here we have limit as n goes to infinity of n raised to 4. You divide this by n cubed. And then also the numerator, you have here 3n over n cubed. And then over 4n cubed over n cubed, and then minus 2n all over n cubed, and then plus 1 over n cubed. And when we simplify this fraction, we get n minus 3 over n squared over, you have here 4 minus 2 over n squared, and then plus 1 over n cubed. And the limit as n goes to infinity in this case is equal to, so this goes to 0. this goes to 0, and then this term also goes to 0. So as you can see here, our numerator goes to, okay, this one goes to infinity. So the numerator goes to infinity and the denominator goes to 4. So therefore, the limit of this sequence is equal to infinity. So therefore, the sequence a sub n is divergent. Now let's.
So now I've listed a few different sequences, and the task is to determine whether each sequence converges or diverges. If it converges, we want to state what it converges to. So in each of these examples, I'm going to use that sequence extension theorem that I just provided in the notes. So in this first example, so we can determine whether this sequence converges or diverges by taking the limit as n approaches infinity of n over n plus 1. Now with this limit, the thing to notice is that I've got the rational expression with the same degree in the numerator and denominator. And so when you have same degree in the numerator and denominator like this, the limit at positive or negative infinity is equal to the ratio of the leading coefficients. So in this case, 1 over 1. So the limit here is 1. You could also use L'Hopital's rule. It's got the form infinity over infinity. So you could take the derivative of the top and the derivative of the bottom, which would also give you 1 over 1. But we're going to see limits of this form a lot. And so it's really best if you can recognize rational expressions, same degree top and bottom. I just do ratio of leading coefficients. It'll save you time. So when the limit is a finite number, as it is here, that means that the sequence converges to whatever that value is. So example 1 here converges to 1. That's our answer. Okay, and I'm going to erase. Well, I won't erase yet. Of n cubed over 2n minus 4. This has the form infinity over infinity, but it does not have same degree top and bottom. It has a higher degree in the numerator, which might tell you something, but if you just think of it as, okay, infinity over infinity, the degrees don't match. Let me apply L'Hopital's rule, just to be sure. So limit as n approaches infinity of derivative of the top is 3n squared, derivative of the bottom is just 2. And so as n approaches infinity, this is just 3 halves times infinity. It's just increasing without bound. This is going to infinity. So remember, when a limit is equal to infinity, we're saying really that the limit doesn't exist. It's not approaching some finite number. It's just increasing without bound. So this limit diverges, which means this sequence right here, number 3, diverges. The limit of the terms does not approach some finite number.
Very much for attending the class. I will end the class here. If you have any questions, you can post the questions to me in our messenger group, right? Or maybe you can post it personally to me through Viber Messenger, and I will definitely get back to you. Thank you very much, and see you people in the next class.